Welcome everybody from Sparx Systems YouTube channel. It's great to have you here today, and once again we're looking at our urban parking system repository that's been designed and developed in Enterprise Architect. The last few videos we've been looking at SysML, and we're going to continue that again today, and I believe we're going to look at state machines within system modeling, or SysML for short. My name's Scott Hebbard. I'm joined by Stephen Maguire. Welcome, Stephen. What can you tell us about how to develop a state machine for SysML in Enterprise Architect?
Thanks for the introduction, Scott, and always a pleasure to be here. The state machine diagram is one of my favorites. It is a very simple diagram, but it gives a huge amount of information and allows a modeler to describe the transitions between discrete states that a part of the system can be in. So it can be something as small as a subsystem or a block, and it can be something much larger as a system itself. So the user will make that decision. And also the state diagram is also from a particular perspective. So, you know, the states that a house could be in, for example, using an example that people are familiar with, it might be, you know, tidy and untidy. It might be, you know, for sale or for rent and all sorts of things. So it depends upon the perspective that you're looking at from the state machine. So having said that, let's get started, and we'll, as always, set our perspective by going to the top right-hand corner of the application. I've been doing some TOGAF modeling. We can drop this down and look at the perspective sets. We can look at systems engineering there and the SysML. We click on that, the tool changes its focus, brings up the builder page, and we can see all of the patterns that are useful for modeling different diagrams in the tool, and also there's some project structures there as well. Let's look at the state machine diagrams there. Simple state machine there. We can see, you know, state A, state B, and some transitions, the lines going between the different states are transitions. And there are triggers and effects and guards and all sorts of other properties on those transitions. We can look at you know, other types of patterns as well, and we can look at, you know, regions there. But we're going to take a look at a simple state machine, Scott, and I encourage people to come back to this and get the productivity gains that you get by injecting these patterns into your model. Simply hit the Create Model button, and that will inject the pattern. I'm going to close the builder page, Scott, and get started with this. So my perspective is SysML. I now need to find a location in the project browser for this. So let's have a look at our systems engineering models that we've done so far. We've got our Boomgate parking there. Now that's a requirements model. So that's Boomgate requirements there. And since we're going to put some other things in, let's just alter the name of that so we're very clear that that is requirements. So Boomgate parking requirements. And let's find a location for our new diagram, which is our state machine. So what I'm going to look at is a block diagram here. We've got subsystems here, and we can see here that we did a block diagram in an earlier video looking at the subsystems of this Boomgate parking system. So the access control subsystem, the payment subsystem, the monitoring system there, subsystem. So let's look at the Boomgate itself. So we had that as a block, which is a part of that subsystem. So we can click on the Boomgate in the project browser there. I'm going to close this diagram for a minute. It was just for me to get orientated to where this Boomgate is located, and it's part of that access control subsystem, obviously. So what I can do now, Scott, is I can select this element, this block element. In previous videos, we've pretty much always selected a package. In some cases not, but I can select the element and I can say new diagram, and go up to the browser toolbar and click on the new diagram icon there, and that brings up the SysML diagrams. And the one that I want is a state machine. So a number of different options under there. I'm just going to choose the vanilla one, state machine, press the create diagram button. That injects the diagram in, and someone else working on this at the time, so I'm just going to close that.
Now so I can see it's embedded that underneath Boomgate, and it's kept the same name. So
exactly, Scott. So it has done that, and it's put a frame there as well. So let's get started, and the first thing I need to do is to put an initial state on. That's what I like to do, is to put the initial state on there. And let's put that on. Not worry about the name for the moment, but let's put some notes in here. We always like to do that. So this is actually not a state, but what's called a pseudo state. So I'm going to put some notes in for that. The other thing that I want to do is, at some point, this thing is going to actually conclude. So it's going to start, but the boom gate, as you know, will go through its operation cycle, pretty much all day and all night if the parking facility is open for those hours. So the other thing I like to do is put on a final. So I'm going to put that final one on there. That is actually that's a final state. And so it is actually a type of state. And I'm going to put some notes in there indicating that the system has been halted and is no longer operational. The boom may be locked, closed, or open. So I'll just put a comma into there. And I'm going to call this system halted. So I like to do that, Scott. Gives me the sort of starting point and the finish point. I know, I've got to put some other things in between this, but at least I've kind of made a start on the diagram. Just correct that capitalization there. Easy to do in the tool. And let's put some other states in. So when nothing's happening in the boom gate parking system, the system is what would be described as idle. Now, I mentioned earlier that it's important that you think about this from a particular perspective, right? So the states are, you could get very, very fine detailed and say, when the boom gate was at an angle of 3 degrees, when it was at an angle of 7 degrees, when an angle of 15 degrees. And people, unfortunately, tend to not be able to abstract up to the right level. So what you're trying to do is to look for the important parts of where some change happens or something significant happens. So imagine you're watching a movie and there's a whole lot of things going on in a particular location. Then suddenly the location changes, or something happens. The people in the movie are sitting down and suddenly they stand up. So these are the things that we're looking for in our state machine, the significant changes of states. So let's drop a state onto the diagram as well, and we'll call this one idle. So that's a word that's commonly used for a system that's not actually doing anything at that particular time. So you could say it was in standby. Let's put some notes into there so we can. So that's a standby state where the system waits for activation while performing basic system monitoring. The gate remains motionless in this start while periodically checking system health and doing other things. So let's put another state in, Scott, and we'll call it the operating state. So let's put that state in as well, and we can put it down here a little bit, and we'll call it operating. So this is the state where things are going along and the cars are coming in and entering and exiting and things. So let's put some notes in for that operational state as well. The primary operational state containing the substates that manage the gate's movement cycle. So this has indicated to us that we're going to have some substates in here. So what I'm going to do is I'm going to put in a relationship between these elements, start connecting them up. The transition there is pretty much the only relationship, so not much to think about there. I'll put a relationship into that. We've got that transition happening, and I'll put a relationship in to my operating state. So that's a transition as well there. And now I want to make this operating state a little bigger. I'll move it up a little bit, and then I'm going to simply drag the corner out there, one of the border points, and I'm going to make it bigger. Notice the frame changes its
frame resizes.
Resizes. Now I'm going to put in some elements inside this one. So an important thing that people miss, Scott, is the fact that we're inside another state, and so we actually need another initial state in here to indicate where this starts. I'm not going to give it a name. It's kind of obvious that that's the starting point. So when that transition targets that operating state, effectively what you're saying is that it's targeting that particular initial. So people might be tempted to put it onto the initial state, but I don't want to do that because the language deals with that by saying that when you enter the state, it'll start at the transition. So what I'm going to do now is I'm going to put some substates in here, and I'm going to put this one as closed. So that's the starting position, if you like, the closed position. And again, I'm going to put in some some details about that. I always like to put in notes, Scott, that tell the story. And so we've got that closed one there. I'm going to put in a transition from this one into the closed, and it's a transition. Now I can keep going with this diagram and create all of the different states in here. So we've got closed. We're going to have an opening state. So let's just put one of those in so we can see what's going on here. Someone might be thinking that you could just put closed and open, but there's some other states that are kind of important with this parking meter. And if you've ever driven into a parking, a tower parking where you've got boom gates, most people in the audience I'm sure would have, that the opening state is kind of significant as well. So we want to put that in there, and we'll draw a connector between there. And we can now look at this connector and put in some notes about it. One of the things I'm going to put in is a constraint. So I'm going to put in a guard, and the guard is going to be valid ticket, right? So if you hadn't got a ticket out of the machine for some reason, or you didn't have some other type of ticketing arrangement, might be some sort of electronic payment thing, then it won't move into this opening state here. So I just click on that. You'll see that pops up on the diagram there. And the other thing I want to do, Scott, is I want to be able to put in some things called activities. So if I click on this guy here, I'm just going to make this a bit smaller, and you can see that the frame will resize. And I'm going to open up the features window. Now, simply to open up any window, the best way to do that is to go to the Start ribbon, and we can go here to the All Windows panel, and we can look at Design, Properties, Collaborate. I think this is more of a property, so I'm going to click on the Properties one. There's the Features window there. Click on that. That's going to open up, and you can see that opened up down the bottom here. And you can see now that Enterprise Architect has prompted you for 3 activities that go on during the state machine operation. So these activities are invoked while the state is specified. So when we come into the state, things that are going on while in the state, and then things that we do before we exit the state. So let's take the closed one, I think, and we'll look at putting some activities in to hear these behaviors. So we're just going to give it a name, and the name is going to be, and the closed one is going to be lock boom gate, and the other one is check for ticket. So the do one is it's sitting there waiting, and it's going to say, look, let's check for ticket. So it's not specifying exactly how that ticket is operating. That will come out in another model, whether it's someone that's got using their smartphone to tap on something and register the time that they've come in, or it's a ticket that's dispensed by the machine.
A little paper ticket.
Paper ticket, yeah, exactly. So now we can say unlock boom gate. And you can see those have gone in there. I can just resize that element a little bit, and you can see now the model's getting richer. But Scott, as always, I like to be able to put in some notes into these. So almost everything in Enterprise Architect, from a diagram to a package, down to an element, down to a feature, parameter, it can have notes on it. So I'm going to select that, and you can see the notes window pops up, and I'm going to put in some notes in there. So the default position where the gate blocks vehicle entry until a valid ticket is presented, the gate arm is locked in the horizontal position, actively checking for ticket validation from appropriate approaching vehicles. So that is the main things that we're doing with our state machine diagram. We've seen how to put initial pseudo states on, how to put a final state on. We've created some states. We've linked them up with transitions. We've put some nested states inside the operating state. So we've got more of those to do. Yep. What I'm going to get you to do now, Scott, is to perform some of your time travel magic. And, let's make a start on completing this diagram, and we'll see you back here in a few seconds.
Welcome back, everybody. I've completed a bit of time travel magic, and we've now got our completed SysML state machine diagram. And it's very interesting. We've got a number of different states. So perhaps you could tell us a little bit about the states and what we're hoping to achieve with the boom gate.
Thanks, Scott. Good to be back here. Yeah, we've done a little bit more work on the diagram, and you can see that we've got three main states, and then also the system halted final state. So that's also a state as well. But we've got the idle, the operating, and then we've put in another state called maintenance. So this is a common thing with any type of cyber mechanical system. You may need to have a period of time that some people call housekeeping or maintenance window, where you do maintenance work on it. So that can happen from an idle state. It might be that the system's idle and you're wanting to do a particular work on the system. It might be from an operating state where it's failed in some way and you need to maintain it. So you can see that there's a transition there from the idle state to the maintenance state, and also from the operating state into the maintenance. And you can see that park entry is closed. So this is not about the boom gate, but some kind of physical barrier that would be put up in front of the parking system, telling motorists that the facility's not currently operational. So we've got that interesting state there, and then we can also go into a system halted, perhaps in the maintenance when they've run some diagnostics or things, they've found out that there's a much more serious problem, and they've got to replace a component or wait for a component to be ordered or something. So that's an interesting state that we've added. Then we've got some more states that we've put in as nested states within our main operating state. So if you think about this, this system, it's going to be switching between this idle state and the operating state quite regularly. So what we haven't got on this diagram, Scott, is another connector that's connecting back between the operating state and the idle state. So that's going to be happening quite regularly. So I'm just going to put that transition in. This is a common thing to happen as you work through your diagram. You start visualizing how that how that works, and I'm going to put that in there. We won't put a label, a guard on that for the moment, but we do have some very powerful simulation features as well, which we will cover in a later video. But I was just simulating that in my mind and saying, we're going from this idle state, we're going to the operating state, it's closed, it's opening, it's open, then it's closing again, then it's closed, and it can go back into this idle state once it's closed. So,
speaking of looking at things, there's a little emergency transition down the bottom, but it doesn't appear to be connected to its own state. Could you maybe describe what's going on there?
Yeah, Scott, really important thing in any kind of facility, whether you're modeling an urban transport system like a train or train system with tunnels and things, there has to be some sort of emergency modeling. And so what this one is doing, this transition, is actually from the operating state through to the open state. So this is for the exit boom gate, and the notes here say the transition ensures that regardless of the active substate, so whichever substate you happen to be in, whether you're in closed, opening, closing, or open itself, in this case, an emergency such as a fire in the facility will trigger the gate to open, allowing vehicles to exit. So, that could be linked then to particular policies or, fire regulations within a city environment that might have to be complied with, and that would all come out in the detailed engineering. And like I said, for train tunnels and things like that, some very, very complex and significant work must go into what happens in the case of an emergency. So that's the beginning of it. We're just showing that has got to be able to open that exit boom. The other thing is, Scott, I've got a legend on this diagram, but curiously enough, it's a dynamic legend, but curiously enough, it's not doing anything. So it's called a status legend. I just want to show people what that's about, because we have covered legends in a number of different diagrams within SysML and other languages and frameworks. If I click on that legend there, you can see now, by just moving this panel across, there's an option there to apply the auto color. Now, this is useful because some people won't want to see that color. It might be distracting to them, and other people that want to look at the status can say, look, let's apply that. So I click that checkbox there and then say save, and you can see now that the EA is dynamically showing the color of elements based on their state. Their state being, are they, let's go back to the properties there in the element, and you can see that this particular element is approved. The opening one has been validated. this one here has been proposed, and we can see this one has been implemented. So by changing those colors, so if I could put this open one, I can say, look, it's gone from in progress to back to completed there. We have a look, validated, implemented, and you can see that's changed that color.
Yeah.
So you can do that for any property. If you look at this legend here again, we can see that the legend is based on the status, and I can edit that and make it based on all sorts of things, including tag values as
and
well.
Difficulty and phase and yeah.
So Scott, that's an introduction to state machine modeling in Enterprise Architect for SysML. This is just the beginning. There is so much within the tool and so many other things that are part of the language that we will cover in future videos. So, all sorts of things like concurrent states, substates, and regions, and lots of other things, and including the ability to simulate these things. So, we have incredible ability to do simulations here, and you can see the state machine one there has got its own item there on the simulate ribbon, and there's lots of different things that we can do. So executable state machines will be the topic of another video. Very powerful feature of the tool. But that's it for state machines, Scott.
Excellent. Well, that sounds exciting. That there's lots more advanced features to come around simulation, and perhaps understanding more how the triggers and various options work there with simulation. So looking forward to that. I'd like to thank everyone for joining us today. It's great to have you here with us. As always, if you've enjoyed this video, we encourage you to like, comment, and subscribe to the Sparx Systems YouTube channel. We always appreciate your feedback. If you have any questions about state machines or executable state machines within Enterprise Architect and SysML, you can reach out to Stephen using his LinkedIn and website credentials that are listed in the video description below. As always, thanks for your expertise. You've made it once again very easy to pull together a complex systems model around a boom gate and make it look very simple and easy. And it tells a nice story about the different states that the boom gate has to go through, which obviously then can help us build better requirements and build a better system. So thanks for that, Stephen. Greatly appreciated.
Always a pleasure to be here, Scott. And just remember, we've only scratched the surface of the tool's capability.